Hi, this is Addy Doyen, Addy Pegbuzz, and Andrew Meinke's demo video for the inverted pendulum using a neural network. To recap the inverted pendulum problems, you're trying to balance an inverted pendulum using a cart that the pendulum can freely rotate up on by pushing a force left or right on the cart, and that's what the neural network will do to control the cart and balance the pendulum. To briefly go over the code that we worked on to solve this problem is we use Jim for the environment setup and Kiros to do the neural network setup. And periodically we save the output of the video to this directory. 10% of the time when the neural network is playing, we inject a random action so it can start to explore other options and continue learning. Epoch size was 20 with batch sizes of 64 data points. And we set the goal it tried to achieve to 50,000. We set this real high because we just wanted to keep going. This is where we initialize our custom goal version of cart pull. Essentially, cart pull has a built-in limit of 200. We did this so we can keep going further. Here's where we initialize the monitor setup. Here's where we initialize our 4 input node input layer, and then 3 layers of 256 nodes for the hidden layer using RELU activation, and then 2 node output layer for left and right command of the neural network. Here, the compile command is where you set up the optimizer. We use atoms as it was suitable for non-stationary objectives and is considered computationally efficient, which is what we like for real-time learning, real-time application. Categorical cross entropy was chosen for the loss parameter, as is deemed suitable when the output should only be 1 on one of the output nodes. So it should be pushing left or right, not either at the same time. And the metric was chosen was accuracy. Here, just printing out some basic data to check the code. Here's a randomizing agent, the sequential neural network agent. Here is where we do the random action, and here's where the agent takes its own step when it controls itself. Here's the sequential training, the sequential neural network agent, getting the information and fitting the data. Here is the actual trial code, initializing the variables, and then actually performing the loop to train the neural network for each event step. Here is the running of the main code. Here we do the initial random training data with the 50 trials, and then here is where we're actually doing the actual training itself. Here is it doing as it's going through the code and doing the new trials and then periodically updating. And here is just some videos of the results. As you can see, initially it does not do so well, but as it goes along, it starts to get better and better and better. That's all. Thank you for watching. I hope you enjoyed.